आप में से कोई बताए तो।
Okay, so good evening and welcome back to the new class. So we are studying hydrogeology, and today is one of the most important classes of hydrogeology, where we are going to talk about the very important, very well-known concept called as the Darcy's law. Okay, Darcy's law. So basically, Darcy's law is one of the very fundamental laws that governs the movement of the groundwater. Okay, groundwater जब move होता है तो उसके कुछ specific principles है, उसके कुछ स्पेसिफिक फिजिकल रूल्स है जिसको ये फॉलो करता है. ओके, सो व्हेनेवर वी आर टॉकिंग अबाउट द मूवमेंट और डायनामिसिटी ऑफ द ग्राउंड वाटर, we can never ignore the Darcy's law. Okay, whenever we are talking about the groundwater movement, we can never ever forget the Darcy's law, because Darcy's law is governing all the movement of the specifically the groundwater. Okay, now before we actually go and jump into the Darcy's law, let's create our understanding. Okay, why? There is one reason that I want you to develop your understanding directly before going directly to the Darcy's law, because almost all the students who have studied hydrogeology do know Darcy's law. Okay, but hardly they know about the basic of Darcy's law, that कि ये बना कैसे है, किस चीज के लिए है. Okay, most of the students are not aware of the fact that what is the basis of Darcy's law. Now, because we are studying at the Darcy's classes, so we need to know its laws very well. Okay, so we'll start with the Darcy's law and its basics today. Okay, so first of all, we need to understand what is groundwater. So as we know it very well, groundwater is the water that resides in the rocks, right? जो पानी ग्राउंड के अंदर रहता है, सॉइल के अंदर रहता है, रॉक्स के अंदर रहता है, उसे हम कहते हैं ग्राउंड वाटर. ओके, नाउ एक रॉक या एक सॉइल के अंदर क्या होता है? ओके, सो फर्स्ट ऑफ ऑल, इफ दिस इज अ सॉइल, ओके, you will have the soil grains, right? You will have the soil grains. Now, along with the soil grains, you also have the empty spaces or the voids, right? Empty spaces or the voids. Now, presence or absence of these voids is totally depends upon whether, okay, presence or absence of the voids totally depends upon the compression of, okay, how compact is the rock or how compact is the soil. Accordingly, these empty spaces will be more or less, right? So these empty spaces, also called as voids, they are basically representative of the important hydrogeological property called as the porosity, right? We all know about it very well, we have studied this, right? हमने इसको दो क्लासेस में बहुत अच्छे से स्टडी किया कि पोरोसिटी क्या होता है, right? Now, porosity is certainly an important property, but when we are talking about the movement of groundwater, okay, whenever we are talking about the movement of groundwater, we need to understand that these voids needs to be interconnected. Okay, these voids, they need to be interconnected. Okay, now considering a situation where voids are interconnected, so you will see what is going to happen. These voids are going to travel across the grain boundaries. Okay, so these voids are basically acting as a tube like structure, isn't it? जो voids होते हैं, जो pores होते हैं, वो basically एक ट्यूब जैसा स्ट्रक्चर बन रहा है, पाइप जैसा स्ट्रक्चर बन रहा है, जिसके अंदर से वाटर फ्लो हो रहा है, right? Now this motion is obviously very slow, right? This motion is obviously very slow. किस चीज पर डिपेंड करेगा ये velocity of the movement? Yes. Uh, I couldn't. Grain size. Okay. Gradient. Okay. Correct. Gradient. Then someone says grain size, or anything else?
Sir, sorting.
Sorting. Okay. We can merge it all together into the grain size. Okay.
Shape.
Let's say texture पे depend करेगा, right? Texture, compaction, etc. Right? Now, if the pores, if the voids are not connected to each other, then there is not going to be any flow of the groundwater, isn't it? अगर pores connected नहीं है तो obviously वहां पर कोई flow नहीं होगा, and I will not be talking about the groundwater flow. But considering the situation where the voids form interconnected tube-like structures, okay, so these green lines are indicating the path of the water flow, right? This is the path along which the water is flowing simply. Okay, water is flowing. Now you will see that water will always flow from high potential to the low potential, right? ज्यादा पानी से कम पानी की तरफ flow होगा, right? That is why we have used this full glacier and half glacier. So water is supposed to move like this, right? From the high potential to the low potential. Now as the water, okay, now, okay, इसे अच्छे से समझने की कोशिश करेंगे, ठीक है? Now as the water is trying to move along the grain boundaries, will there be resistance or not?
There will be resistance.
And what will be the reason for this resistance?
Sir,
Correct. Adhesive forces, right? Adhesive forces, right? Then surface tension, okay, etc. Right? Also, it depends upon the viscosity of the fluid, isn't it? But because we are talking about hydrogeology, so we are basically always worried only about water. But if we have any other fluid, for example, honey, then there will be even more resistance. That will be because of the cohesion of the fluid, right? So because of the adhesive forces at the grain contacts, water is going to have lot of resistance, because of which, okay, because of which when the pores, okay, when the pores, they are irregular and narrower, okay, then the flow path will be irregular, माने straight नहीं रहेगा, and narrow मतलब एकदम पतला, right? It will be a very thin tube through which the water is flowing. Similarly, if I have coarser rock, okay, if I have coarser rock so that the grains are larger, okay, grain large हो जाएगा, okay, तो resistance relatively कम लगेगा या ज्यादा लगेगा? apparent resistance कम होगा या ज्यादा होगा अगर grain size बड़ा हो जाएगा?
कम होगा.
Resistance will be lesser, right? Resistance
सर
will be,
आपकी आवाज कट गई थी.
oh, okay, I'm asking, if the grains are smaller, okay, if the grains are finer, then there will be more adhesion, because of which there will be more resistance and the path will be irregular and narrower. But if the grain size is coarser, then obviously the adhesion will be much lesser, and because of which the path of the water flow, path of the tube will be regular and open, right? So path कैसा मिलेगा flow का? ऐसा, right? It will be broad, right? The path of water will be much broader in the coarser rock, and in the finer rock, it will be much irregular and narrower because of the resistance. Okay, because of the resistance. Now, the property, okay, the property of soil, okay, this property of soil or the rocks, okay, this property of the soil or the rocks which allows the liquid, okay, which allows the liquid to flow through it is called as the permeability. Getting my point? The property of soil which allows the liquid to flow through it, okay, through its voids is called as permeability. So we have already seen this, but we will just simply revise for a while. Okay, presence of rocks will make the rock porous, right? And if the pores are interconnected, then it will be also called as permeable, because it is going to permit the flow of water, right? Some rocks like shales, okay, and clays, they are certainly porous, but the pores are not interconnected, causing the rock to be impermeable or simply impervious. Okay, impermeable or impervious, right? So this is a very important property, permeability. It is a very, very important property. Now, why are we talking about permeability when the topic is Darcy's law? Okay, the simplest question is that why are we even talking about permeability जब टॉपिक है हमारा डार्सीज लॉ। Initially, at the starting of the lecture itself, I cleared out that Darcy's law talks about the movement or the flow of the groundwater. Okay, Darcy's law किसके बारे में बात करता है? ये बात करता है ग्राउंड वाटर के फ्लो के बारे में. So flow होने के लिए permeability is the most obvious phenomenon. This is the most obvious prerequisite. If the rock is not permeable, the water will not be able to flow, right? So permeability can also be defined as the ease with which water can flow through the soil or the rocks. Okay. Now, what is the relationship between the coarseness and fineness, or simply the grain size of the sediments or the rocks? Okay. If I have larger soil particles, okay, if I have the larger soil particle, then naturally the volume of voids will also be larger, isn't it? If I have the larger rock particles, sediments, or soil particles, the volume of voids will also be larger. In such situation, there will be better connectivity of the voids, right? I will have larger grain size, larger volume of the voids, and there will be better connectivity of the voids. As a result of that, there will be higher water flow. So I will say that this rock or this soil has high permeability, right? I would say that such a rock has high permeability. Okay, I will say कि ऐसा रॉक जो होता है जिसमें कोर्सर साइज है, वॉल्यूम ऑफ वॉइड्स बड़ा बड़ा है, अच्छे से पोर कनेक्टेड है, तो ऑब्वियसली इसमें से वाटर बहुत इजीली फ्लो होगा. तो ऐसे रॉक को हम कहेंगे हाईली परवियस रॉक. ओके, हाई परमियाबिलिटी. ओके, हाई परमियाबिलिटी. सो there is one more word, hydraulic conductivity, K, right? Can somebody define what is hydraulic conductivity? Do you remember? Recall this thing? Anyone?
It was the ability.
It was the ability.
Are flowed by a unit area.
Correct. So what was the difference between permeability and hydraulic conductivity?
Hydraulic conductivity is found of quality of aquifer. These are wells, aquifer wells, and porosity is a general rock soil porosity.
Correct. Hydraulic conductivity is a measurable phenomenon, right? It is basically a measurable phenomenon. Okay, it is a measurable phenomenon which represents the ease with which the water can flow through the rock, right? The ease with which the groundwater can flow through the rock is called as the hydraulic conductivity. Now, for the different types of liquids, okay, liquid 1, liquid 2, and liquid 3, for 3 different liquids, the value of K will also be different for the same soil. Okay, for the same soil or the same rock, okay, for the different liquids, the value of K will be different. Why?
Sir, the porosity and
Viscosity.
everything will be different.
पोरोसिटी का तो कंसेप्ट नहीं आना चाहिए यहाँ. यहाँ आना चाहिए कि लिक्विड्स अलग है, रॉक तो वही है, तो पोरोसिटी तो वही है सबका.
Viscosity.
करेक्ट, विस्कोसिटी की वजह से, राइट? जस्ट 1 सेकंड प्लीज. Okay. So it is basically because of the viscosities. Okay. Now, how are viscosities going to affect the hydraulic conductivities? Viscosity अलग होने से क्या होता है?
उसका सर मूवमेंट रेजिस्ट होता है अगर वो ज्यादा विस्कस रहे.
एग्जैक्टली, बट उसको आप साइंटिफिकली कैसे पुट अप करेंगे?
रेट ऑफ फ्लो चेंज होगा.
Yes, rate of flow will be changed, yes. बट हाउ आर यू गोइंग टू टॉक अबाउट कि फ्लो अच्छा या बुरा कैसे होता है? व्हाट डिफाइंस फ्लूइड में फ्लो अच्छा या बुरा कैसे डिफाइन होता है? विस्कोसिटी इज द वर्ड टू दिस पर्टिकुलर प्रॉपर्टी। ओके, लेकिन ये क्या होता है?
वेलोसिटी, फ्लो रेट ऑफ फ्लो,
आपका आवाज समझ में नहीं आ रहा है अखत।
विस्कोसिटी इज इनवर्सली प्रोपोर्शनल टू रेट ऑफ फ्लो।
ओके, हाई हेड टू लो हेड फ्लो ऑफ वाटर, नो। बेसिकली
The more
विस्कोसिटी का
viscous water will be sluggish flow.
yes, that is obvious, I know, everyone knows this very well कि विस्कोसिटी ज्यादा का मतलब है कि फ्लो नहीं होगा, विस्कोसिटी कम का मतलब है कि बहुत इजीली फ्लो होगा। दैट इज ट्रू, बट व्हाट हैपेंस व्हेन द विस्कोसिटी इज हायर एंड व्हाट हैपेंस व्हेन द विस्कोसिटी इज लोअर, सो दैट द फ्लो कंडीशंस चेंज? क्या होता है हाई विस्कोसिटी में ऐसा?
सर वो
सर
पार्टिकल के अंदर का
लैमिनार
कोहेजन बढ़ जाता है। जो हमारा लिक्विड है उसके जो इंटर पार्टिकल अट्रैक्शन है वो ज्यादा रहता है।
Correct. Cohesion between the particles will increase, first of all. Secondly, the fluid will resist the internal deformation, right? The material, the fluid will resist the internal deformation. Okay, internal deformation. ये क्या होता है जानते हैं? Internal deformation. Internal deformation refers to changes in bond lengths, okay, angles, etc. इस लेवल पे जो डिफॉर्मेशन होता है उसको रेजिस्ट करता है। ओके, देन समथिंग बिकम्स विस्कस। ओके, देन समथिंग विल बिकम विस्कस। ओके, नाउ नाउ लेट्स चेक कि आपका विस्कोसिटी का अंडरस्टैंडिंग कितना साउंड है। ओके, आई एम गिविंग यू टू एग्जांपल्स। ओके, आई एम गिविंग यू द टू एग्जांपल्स। वन, ओके, honey. Is it more viscous or less viscous than water?
More
more
viscous.
viscous.
It is certainly more viscous. Okay. Now, if I have water, okay, it is certainly less viscous than honey, right? Than honey, water is certainly less viscous, very easily fluid. But if I take hot water and add some flour to it, okay, atta, okay, गेहूं का आटा for example or मैदा, okay, and make a paste, okay, एक पेस्ट बना लेता हूँ, या फिर आई वुड यूज द कॉर्नफ्लावर, okay, कॉर्नफ्लावर, ठीक है, then what is going to become more viscous, honey or this particular mixture?
Mixture.
It's
Right, the mixture will be highly viscous now, right? ये ज्यादा विस्कस हो जाएगा। okay, now what is the reason behind highly viscous mixture? इसमें तो वाटर था जिसका विस्कोसिटी लो था, एंड यहाँ पे तो फ्लू सॉलिड है, सो इस मिक्सचर का विस्कोसिटी हाई क्यों हुआ? Is it also because of increase in resistivity to the internal deformation? इंटरनली डिफॉर्म नहीं होने दे रहा इसलिए?
सर इसमें वो नया आपने डाले है लार उसके कारण।
हाँ, तो ऐसे आंसर नहीं ना होगा, अब बताना पड़ेगा कि क्या उसके वजह से इंटरनल डिफॉर्मेशन बढ़ रहा है या क्या हो रहा है।
वाटर मॉलिक्यूल्स को क्लाउड अपने मॉलिक्यूल्स के साथ कंबाइन कर लेता है, then चेंजेस होना
करेक्ट,
मुश्किल हो जाता
correct, very good. The molecules of the corn flour will combine the water molecules, and hence now water molecule is not freely available to move. Okay, अब water molecule available नहीं है freely move होने के लिए, because of which इसका viscosity बढ़ रहा है, right? Otherwise जो fluid मैंने उसमें डाला है, okay, अदरवाइज जो मैंने फ्लूइड उसमें डाला है वाटर, उसकी विस्कोसिटी कम ही है, राइट? इसका वेलोसिटी, इसका विस्कोसिटी एनीवे कम ही है, वो विस्कोसिटी में कोई फर्क नहीं है। ओके, नाउ नाउ व्हेन यू ऐड द फ्लावर टू द वाटर, व्हाट हैपेंस टू द वॉल्यूम ऑफ फ्लावर? ये इंक्रीज होता है या डिक्रीज होता है?
डिक्रीज।
है, इंक्रीज होता है।
इंक्रीज हो जाता है,
Increase
फूल जाता
होगा।
है ना, इंक्रीज हो जाता है। आपने कभी अगर सूजी बनाया होगा, सूजी का हलवा वगैरह बनाया होगा, तो व्हेन यू ड्राई रोस्ट द सेमोलिना और रवा और सूजी, okay, it is very less, but when you add the milk or water, then you will see it will expand, right? इस expansion को हम क्या कहते हैं टेक्निकल टर्म्स में? जो एक्सपांशन हो जाता है पानी लगने के बाद में, तब हम इसे क्या कहते हैं? बताओ। संचित?
fermentation.
No, not fermentation. Okay, anyway, I'll go to there in the next slide. Okay. Anyway, we were talking about the hydraulic conductivity. Okay. So hydraulic conductivity के reference में हमने देखा for the different fluids and the same soil, the value of K will be different. Okay. Similarly, if the soils itself are different, okay, then also for the same fluid, the value of hydraulic conductivity will be different. है ना? ऐसा तो फिक्स नहीं है कि वाटर के लिए हाइड्रोलिक कंडक्टिविटी हमेशा फिक्स रहती है, राइट? ऐसा जरूरी नहीं है, राइट? ये डिपेंड करता है रॉक पर, है ना? तो फ्लूइड के हिसाब से के का वैल्यू चेंज होगा, रॉक के हिसाब से भी के का वैल्यू चेंज होगा, राइट? नाउ we were talking about the coarser rocks first, right? Gravels. Okay, gravels. So for the gravels, the hydraulic conductivity, which is measured as centimeter per second, is very high, more than 1 centimeter per second. Okay, but as I decrease the grain size from gravel to sand, then sand to silt, and silts to clay, I see that the hydraulic conductivity is negligible, right? Hydraulic conductivity is negligible, 10 to the power minus 7 centimeter per second. मतलब कितना? Only a few micron, right? Only some microns per centimeter. इतना slowly move हो रहा है. So I can say that the clays are least permeable, right? The clays are least permeable, where are the gravels, which are coarse grain rock, they are most permeable, right? So permeability grains, coarser grains में ज्यादा, finer grains में कम. Okay. Now, if we talk about the finer minerals, finer rocks, okay, like clays, okay, here what is going to happen? It generally has something called as the flocculated structures. Okay, पानी पी करके फूल जाना, flocculated structures. Okay, flocculated structures. Okay, so what is going to happen? Because of its small grains, small soil particles, there will be certainly very high void ratio. Okay, hence very high volume of voids. So porosity is very high, isn't it? As we can see in the diagram, yes, porosity is very high. But because of the poor connections between the pores, it is having least permeability, right? It is having least permeability because clays especially, they have the flocculated structures. पानी पी करके फूला हुआ, right? They have flocculated structures, because of which you will not have interconnected pores, and hence, okay, and hence, even after having large amount of voids, the clay soils are less permeable. Why? Because the clay forms irregular tube. Okay, as you can see in this diagram, that the water cannot flow easily, right? Water cannot pass continuously. इधर तक आया खत्म, there is no more connectivity. यहाँ तक आया, then खत्म, then एक नया channel, then एक नया channel, then एक नया channel. Okay, and so on. But water is not able to flow continuously, right? Because of which the clay soils are less permeable, right? Because of which they are the less permeables. Okay, now that was about the character of the rocks, कि भैया permeability क्या है and ये किस चीज पर डिपेंड करती है. इन सारे एक एक स्लाइड का बहुत इंपॉर्टेंस है, हाँ, डार्सीज लॉ में, तो इसको एकदम केयरफुली कंसीडर करना है. आपको आता है, ठीक है, हर चीज, लेकिन फिर भी थोड़ा सा ध्यान ज्यादा देना है, ठीक है. नाउ let us say, okay, let us say I have two wells, okay, I have two wells, okay, ये क्या रहा है, okay, I have two wells. Okay, let's say well number 1 and well number 2. Okay. So as you can see in the diagram, it is very clear that water has to flow from well number 1 to well number 2. Right? डायग्राम देखने से क्लियर पता चलता है कि वेल नंबर 1 से वेल नंबर 2 के तरफ में पानी फ्लो होगा. क्यों ऐसे लगता है? क्या आपको लगता है ऐसा कि ऐसा ही होगा? डायरेक्शन यही है येलो एरो वाली.
नहीं सर.
Then from 2 to 1.
हाँ.
Which arrow is correct? Red one या blue one?
Red one.
Red one is correct. So water is going to flow from well number 2 to well number 1. Why do you think so?
उनका वाटर लेवल हाई है ना 1 से.
कहाँ? 1 का वाटर लेवल इधर है, 2 का वाटर लेवल इधर है, तो 2 तो नीचे ना हुआ.
1 to
1 to 2, right? Water is supposed to flow from well number 1 to the well number 2, right? Water should basically flow from well number 1 to well number 2 because of the difference of hydraulic head, right? Because of this difference in the hydraulic head. So the obvious question arises, what is this hydraulic head, right? ये hydraulic head क्या होता है? Okay, so hydraulic head is basically nothing but the mechanical energy of the point at the point, okay, by the virtue of its elevation. Okay, because of by the virtue of its elevation. Now, according to the Bernoulli's principle, okay, according to the Bernoulli's principle, any water molecule when it is flowing, okay, any water molecule when it is flowing, it will always have its energy represented by 3 heads. Okay, इसकी energy के 3 components होंगे. First is its kinetic energy, which is by the virtue of its movement, okay, or velocity. So that is called as the velocity head. Okay, so the total energy at one particular point is represented by one velocity head. Secondly is the pressure of the overburden. Okay, pressure of the overburden. ऊपर में कितना rock है उसके accordingly pressure. So that is called as the pressure head, right? That is also called as the pressure head. And third is the elevation. Okay, elevation. Okay, elevation जब आता है, okay, तब obviously I need to set something called as a datum. I need to set a particular depth from which I'm going to calculate the elevation, because here we are not talking about the height, we are always talking about the underground, है ना? हम अर्थ के सरफेस के ऊपर की बात नहीं कर रहे हैं, हम अंदर की बात कर रहे हैं. सो अंदर में मैं क्या करूंगा, आई हैव टू इमेजिन अ स्पेसिफिक डेटम, स्पेसिफिक लाइन और अ प्लेन फ्रॉम विच आई एम गोइंग टू मेजर द एलिवेशंस ऑफ वन पर्टिकुलर पॉइंट. ओके, सो इफ दैट एलिवेशन इज हायर, ओके, इसको अच्छे से समझिए, ट्राई टू अंडरस्टैंड माय क्वेश्चन फर्स्ट, ओके, एंड देन थिंक अबाउट द आंसर. ओके, if this elevation, okay, यहाँ पर मैं लेट से एक पेड़ बना देता हूँ so that you will understand कि this is the surface, okay, surface of the earth. Okay, if this elevation is higher, then this point will be deeper or shallower?
Sir, can you repeat?
Yes, if I am considering one particular datum like this, okay, and this is my earth surface, then this particular point P is deep or shallow. If I increase this elevation, then point P will become deeper or shallower. That is what I'm asking.
Shallower.
Shallower, क्योंकि ये जैसे ऊपर जाएगा, है ना, तो डेटम से ऊपर लेकिन सरफेस से पास. So it is going to become shallower and shallower eventually, right? It is going to become shallower and shallower, right? So for any particular particle, okay, its total energy is actually represented by 3 factors: velocity head, pressure head, and elevation head. Okay, pressure head, elevation head, and the velocity head. Now, as I said, we need to have one particular datum, okay, above which we are going to increase the measure the elevation, okay, which is also written as Z. In some cases, it will also be written as H. Okay, it is also going to be written as H. Now, according to Bernoulli's principle, we saw कि velocity head, pressure head, and elevation head तीन होगा, but as we know, we are talking about the pore spaces in the rocks, right? So what is going to be the velocity? Is it going to be high? No, it is going to be very insignificant. That is why velocity head is can be considered to be zero, and the total energy of the system, okay, at a one point can be represented by pressure and elevation largely. Okay, we can ignore the velocity head, okay, and we can only rely upon the pressure head and the elevation head, because we are talking about the groundwater movement, which is very, very, very slow. Okay, so velocity head can be considered to be zero, okay, in most idealistic situations. As a result of this, okay, as a result of this, the total energy or the total head or the total, understand this word, potential at a point can be represented by two heads only, pressure head and the elevation head, right? किसी भी point का total overall potential can be measured by pressure head and the elevation head. Okay, now here we have two wells. Okay, यहां देख करके आपको क्या लग रहा है, कहां से कहां जाएगा पानी? इज द एरो रिप्रेजेंटिंग द ट्रू डायरेक्शन ऑफ मूवमेंट ऑफ ग्राउंड वाटर और नॉट?
Yes, sir.
Correct. The diagram is showing a very correct, very expected direction of movement of the groundwater. The reason is that you see here the elevation is much higher than this, right? Here H is different. Okay, I would say H1 and either H2. H1 is much higher than H2, and hence water is flowing from H1 to H2, right? हमेशा high से low की तरफ पानी जाएगा, right? Now you see here, my elevation head can be represented by Z. Okay, from one particular datum, let's say my this line is datum, let's say. Okay, मेरा baseline है datum, for example. Okay, so Z is my elevation head, and P, okay, all rho G is the total pressure. Okay, this is my pressure head, for example. Okay, this is my pressure head. Okay, this is my pressure head. Now, as you can observe, okay, at point A, okay, इसको बहुत अच्छे से समझिए, ठीक है? ग्राउंड वाटर का कंसेप्ट यहाँ पे आपको मैक्सिमम क्लियर हो जाएगा. Okay, at point A or at well A, you see that it is at higher elevation than the B, right? ZA is much higher than ZB, and hence water can flow from well A to well B. Are you getting my point? समझ में आ रहा है आपको?
हाँ सर.
Okay. Now elevation head at A is much higher than the elevation head at B, and hence water is flowing from A to B. Okay. Now I'm changing the slide. Okay. In this slide, you observe A. Okay. You can also draw the diagram. Okay. Just draw the diagram just because you will have the reference. Okay. Draw this very simple diagram. Okay. Don't do it too much. Okay. Just draw the relative lengths of the elevation heads and the pressure heads for the both. Okay, just take one moment, 1 minute. Okay. सिंपल सा डायग्राम बनाइए बस. डन, चले आगे। Okay, now in the next slide, now you see, okay, what we have done. Okay, now what we have done. Okay, I have managed the diagram so that, sorry, एक slide और आगे आ गया मैं. This was my first slide. This is my second one. Okay, here you see the elevation head at A is still higher than B, right? So by nature, water should actually be flowing from A to B. But what I have done, I have increased the pressure head at B. Okay, पहले के डायग्राम में देखिए प्रेशर हेड कैसा था, बी में ज्यादा था, बट अब मैंने क्या किया है, बहुत ज्यादा ऊपर कर दिया, राइट? अब मैंने प्रेशर हेड बहुत ज्यादा इंक्रीज कर दिया, बिकॉज ऑफ विच, okay, because of which the water level has risen at B, and as a result of that, water will now flow from B to A and not from A to B, right? Here you see the hydraulic head at A is at less than the hydraulic head at B, right? Hydraulic head at A is less than hydraulic head at B, and hence water will be flowing from B to A. So it's not only the elevation, it is also the pressure. अब ये प्रेशर कहां से आएगा बताइए, ये आपको पता है, हम लोग पढ़ाए हैं, ठीक है? बताइए, जिस प्रेशर की हम बात कर रहे हैं, कॉम्पैक्शन रॉन्ग,
Hydrostatic pressure.
लिथो
Hydrostatic pressure.
हाइड्रोस्टैटिक प्रेशर, या बट यू सी इसका डेप्थ इतना है, इसका डेप्थ इतना ऊपर है, तो
Overburden pressure.
ओवरबर्डन प्रेशर तो इस पे कम रहना चाहिए ना, देखिए।
वाटर नीचे से आ रहा है ना सर?
अच्छा, आपको डायग्राम का कलर स्कीम का अगर आपको कंफ्यूजन हो रहा होगा तो आई विल जस्ट क्लैरिफाई. ओके, this green part, olive green part, is the saturated zone. Okay, and this brown part is the unsaturated vadose zone. Okay, now you tell me. Gravity, no. Confinement का concept याद है? Aquifers के confinement का. It is possible that at B there is some impervious layer which is causing the pressure at B much higher than at A, because उसी का तो रीजन हो सकता है कि प्रेशर हेड इतना हाई रहेगा. ओके, प्रेशर हेड इतना हाई रहेगा. ओके, so in such situations it is possible that the water can flow like this. Okay, even though apparently the hydraulic head or the water level apparently A में ज्यादा दिख भी रहा होगा, फिर भी उल्टा वाटर फ्लो होता हुआ दिखेगा. दैट इज बिकॉज ऑफ द डिफरेंस इन द प्रेशर हेड्स. ओके, थर्ड पॉसिबिलिटी, बोथ आर एट इक्वल्स. ओके, दोनों इक्वल है. ओके, hydraulic head at A is equal to hydraulic head at B. In this situation there will be no groundwater flow because कोई gradient ही नहीं है, right? Both H's are same, HA and HB are same, so there will be overall no water flow, zero water flow. Okay, there will be zero water flow. Now let's consider one more situation. Okay, let's consider one more situation where B, okay, where B, which is at much less elevation than A, can be supplying water to A. Okay, जो अभी मैंने आपको ऑलरेडी एग्जांपल दे दिया. ओके, पहले ही आपको एग्जांपल दे दिया because I was being very impatient about it. Okay, this can happen when the point B is under high pressure. Okay, whenever there is high overburden because of the confining beds, okay, the rho B can be HB can be much larger than the HA, and hence water can also flow from B to A. Okay, so it is not only okay, it is not only the elevation which is important. Also, you need to look at the pressure head. Okay, pressure head depends on lot of things. Okay, elevation of the well. Okay, then the depth of the base of the well. Okay, then what type of rocks are there in the confinement, ऊपर और नीचे कैसे टाइप का रॉक है, स्पेशली ऊपर में. ओके, उस एरिया का एक्विफर का डिप कितना है. ओके, उस एरिया का जनरल स्लोप कितना है, ग्राउंड सरफेस का स्लोप कितना है, इन सब पे हाइड्रोलिक हेड बेसिकली डिपेंड करेगा. ओके, सॉरी, प्रेशर डिपेंड करेगा जिसके ऊपर हाइड्रोलिक हेड डिपेंड करेगा. ओके, in either situations, okay, fluid will always flow from the high hydraulic head to the low hydraulic head. Okay, from high hydraulic head to low hydraulic head, water will always flow from high hydraulic grade to low hydraulic head. Okay, so whenever you have something high something low, then there will be a gradient, right? Gradient मतलब एक slope develop हो जाएगा, high से low की तरफ जाने वाला एक slope develop हो जाएगा. So this slope is called as the hydraulic gradient. Okay, mathematically which is written as delta H by L. Okay, delta H by L. Okay, delta H by L. Okay, where delta H is the difference between the hydraulic heads between the 2 points. Again, for example, if I have well A and well B. Okay, so hydraulic head at A minus hydraulic head at B is going to give you HA minus HB is going to give you the delta H. Okay, and the distance, lateral horizontal distance between the two is L. So basically delta H by L is the hydraulic gradient. Okay, hydraulic gradient. And how do we quantify it? Let us say if the hydraulic head difference is 2 meters. Okay, वेल ए एंड वेल बी के हाइड्रोलिक हेड में डिफरेंस है एलिवेशन में केवल 2 मीटर्स का, एंड द टू वेल्स आर सेपरेटेड बाय द डिस्टेंस ऑफ 1000 meters, then the gradient can be written as 2 divided by 1000, which will be 0.002. Okay, 0.002, that will be the hydraulic gradient. Had there been no hydraulic gradient, okay, water will never flow from one point to the another. ओके, अगर हाइड्रोलिक ग्रेडियंट नहीं रहेगा तो वाटर एक पॉइंट से दूसरे पॉइंट तक कभी नहीं फ्लो होगा. ओके, नाउ considering a block of rock, okay, of length L, okay, considering a block of rock of length L, okay, and area of cross section A, okay, जिसका area of cross section A है and length L है, ऐसे रॉक को अगर हम कंसीडर करते हैं एंड उसमें से आउटकमिंग वाटर है लेट्स से Q, ओके, फॉर द गिवन हाइड्रोलिक हेड. ओके, यहाँ पे दिया हुआ हाइड्रोलिक हेड डिफरेंस, ठीक है, दोनों एंड्स पे हाइड्रोलिक हेड का डिफरेंस है, बिकॉज ऑफ विच लेट्स से देयर इज अ डिस्चार्ज Q. ओके, डिस्चार्ज Q. सो velocity can be written as Q divided by A, right? This is one of the equations, continuity equations that we have studied in the last class, right? Velocity of the flow of the groundwater through the rocks can also be written as discharge divided by area of cross section, right? Discharge divided by area of cross section, right? Amount of water coming through the given area of cross section is also the velocity of the groundwater. Now what we can do is, okay, अब हम क्या करेंगे, for the different values of hydraulic heads, sorry, hydraulic gradients, I can draw the different velocities. Okay, now tell me what will be the difference. For example, if the hydraulic gradient is 0.01, 0.008, 0.006, 0.004, 0.002, 0.001. Now, how will velocity change? In the direction of arrow, will it increase or decrease? हाइड्रोलिक ग्रेडियंट कम हो रहा है तो वेलोसिटी बढ़ेगी या कम होगी?
कम होगी.
कम होगी, राइट? ऑब्वियसली कम होगी. सो लेट्स से आई एम जस्ट गिविंग रैंडम वैल्यूज. ओके, 90, 85, 80, 75, 70, 65. Isn't it? So I can say that Q discharge directly relates to the delta H. Can I say that? I can say that hydraulic gradient पर velocity depend करती है, right? So if I am to draw the graph, okay, if I am to draw the relationship between the hydraulic gradient and the velocity of the flow, I'll get a graph like this, right? I'll get a straight line passing through the origin. So I can say that there is a direct relationship between the hydraulic gradient and the velocity of the flow. Obviously, there will be a limit to it. Okay. Obviously, there will be a particular limit to it, which is लॉजिकल हाइड्रोलिक ग्रेडियंट का जो भी रिलेशन होगा उसका एक लिमिट रहेगा अप टू विच देयर विल बी अ डायरेक्ट रिलेशनशिप ओके सो accordingly I can classify the flow of the fluid into three different zones. Okay, accordingly I can classify the flow of the water into three zones. Zone 1, which is also called as the laminar flow, then zone 3, which is also called as the turbulent flow, and in between the two I will have the transient zone. Okay, transition zone, not transient zone. Okay, transition zone. This has to be the transition zone. Okay, transition zone. What do you observe in laminar flow is that there is a direct relationship between the velocity of the flow and the hydraulic gradient, right? I can say Q is directly proportional to delta H, right? Q is directly proportional to the delta H. Whereas in case of turbulent flow, okay, turbulent flow में क्या हो रहा है? हाइड्रोलिक ग्रेडियंट ज्यादा बढ़ रहा है लेकिन वेलोसिटी कम बढ़ रही है. सो आई कैन नॉट से देयर इज अ शार्प रिलेशनशिप, बट यस देयर इज स्टिल डायरेक्ट रिलेशनशिप. ओके, नॉट इनवर्स. ओके, बट the relation is not a straight line. It is highly irregular line. Okay, the line is very much irregular. Okay, the line is very much irregular. Accordingly, okay, accordingly we have two types of flows, the laminar flow and the turbulent flow. Okay, laminar flow and the turbulent flow. The laminar flow is a flow when the flow lines or any molecule, okay, which is in motion will never cross the paths with any other motion particle. अगर एक पार्टिकल इस लाइन के अलोंग जा रहा है तो कोई दूसरा पार्टिकल उसके पाथ को कट नहीं करेगा. Okay, all the flow lines will be streamlined. All the flow lines will be parallel to each other and they will never intersect each other. That is called as the laminar flow. Whereas there is turbulent flow, okay, where the flow lines are random. They are always cross-cutting each other, 1 and 2. Okay, water is flowing through eddies, right? The water is flowing through the eddies. है ना? Water is flowing through eddies. Okay, that is called as the turbulent flow. And then there is the laminar flow. Okay, then there is the laminar flow. In the laminar flow, there is a direct linear relationship between the hydraulic gradient and the velocity of the flow, which is eventually lost in the transition and the turbulent flow. Okay. This relationship, okay, this relationship between the discharge, between the velocity of the groundwater flow and different parameters like the elevation, okay, like the area of cross section, okay, like the length of the tube, was all observed by this person known as Henry Darcy. Okay, so Henry Darcy was not basically a hydrogeologist. Okay, he was not basically a hydrogeologist. He was basically working on a sand filter. Okay, he was basically working on a sand filter. Okay, so what was he doing? Okay, what actually he was doing was, okay, he had a tube, okay, in which he filled some sand. Okay, he wanted to enter water from one side and expecting the clean water from another side. Okay, at the same time he wanted that the water should be much cleaner also, but the rate of purification should also be very high. Okay, so for which what did he do? He used soils of different grain sizes. Okay, soils of different grain sizes, then tubes of different lengths, tubes of different diameters. Okay, and every time he got a different result. Okay, so on the basis of his observations, he gave three different relationships. First of all, he said that this Q discharge is directly proportional to the hydraulic head difference. Okay, hydraulic head difference कैसे? पहले डार्सी जी ने अपना ट्यूब हॉरिजॉन्टल रखा, तो देयर वाज डेल्टा एच इज इक्वल्स टू 0, सो देयर वाज नो वाटर, डिस्चार्ज ऑल्सो 0. ओके, जब इन्होंने इसको इंक्लाइन किया तो इन्होंने देखा कि भैया एक एंड पर दूसरे एंड पर पॉइंट ए एंड पॉइंट बी पर हाइड्रोलिक हेड डेवलप हो गया है. ओके, बिकॉज ऑफ विच नाउ देयर इज डिस्चार्ज. सो ही ऑब्जर्व कि जितना हाइड्रोलिक हेड में डिफरेंस रहेगा उतना ही अच्छा डिस्चार्ज आएगा. सो क्यों ना मैं अपने फिल्टर को वर्टिकल अरेंज करूं. ये पहला इन्होंने इससे काम किया. सेकेंड, व्हाट डिड ही ऑब्जर्व दैट लॉन्गर द ट्यूब, ओके, लेसर वाज द डिस्चार्ज. ओके, लॉन्गर द ट्यूब लेसर वाज द डिस्चार्ज. मतलब अगर इस ट्यूब का लेंथ L है तो जितना L बढ़ाते गए उतना ही Q कम होते गया. So he said that there is inverse relationship between the length of the tube. Okay, length of the tube. Also, he observed that while using the tube, he took multiple materials. He took a tube like this, then he took a tube very thin like this. Okay, then he observed that it also matters on what is the area of cross section, है ना. ट्यूब आप मोटा ट्यूब ले रहे हैं या पतला ट्यूब ले रहे हैं उस पर भी डिपेंड कर रहा है. He observed that the discharge is again directly proportional to the area of the cross section. Okay, area of the cross section. Okay, so on the basis of his observations, okay, on the basis of his different observations, he gave one law which is eventually called as the Darcy's law, where he said that the discharge is proportional to A delta H divided by L. Okay, where A is the area of cross section, delta H is the hydraulic gradient, and L is the length of the tube. To remove the sign of proportionality, we can introduce a factor, okay, constant known as K. Okay, K, which is nothing but your hydraulic conductivity. So I can say that Q, okay, I can say that Q is equals to Ka delta H by L. So this equation stands as the Darcy's law. Okay, this particular equation stands as the Darcy's law. Okay, ये equation को हम कहते हैं Darcy's law. Now, yes sir.
यस सर, इनसे पूछ रहा हूँ, कोई बताएगा हेनरी डार्सी कहाँ के थे? हेनरी डार्सी की कंट्री का नेम कौन बताएगा? कहाँ के थे हेनरी डार्सी, कोई बताएगा? ये ना इंटरव्यू में पूछा गया इसलिए मैं कह रहा हूँ. बिल्कुल सही आंसर. ये इंटरव्यू में पूछते हैं, मेन इंटरव्यू में. हाइड्रोजियोलॉजी का डार्सी का तो डेफिनेटली ही पूछते हैं, ये बात ध्यान रखना. वेरी इंपॉर्टेंट क्लास आपके लिए. ओके सर, कंटिन्यू सर. थैंक यू.
Okay. बेसिकली हेनरी डार्सी वाज बेसिकली फ्रेंच इंजीनियर. ठीक है, फ्रांस से थे. ठीक है, फ्रेंच इंजीनियर. ठीक है. सो बेसिकली डार्सीज लॉ इज नॉट ओनली K into A into delta H divided by L. There is lot more than that. Okay, there is lot more than that. उसमें हम बहुत सारी और चीजों को हम डिराइव कर सकते हैं. ठीक है. So basically this is how we arrive to the Darcy's law. Okay, so today's class was only about how do we arrive to the Darcy's law, कि हम Darcy's law तक आते कैसे हैं. हमें Darcy's law अगर अच्छे से समझना है, ऐसे समझना है कि एक बार समझना है, बाद में जीवन भर उसको कभी नहीं भूलना है. ओके, उसके सारे न्यूमेरिकल्स भी सॉल्व करना है, उसके सारे MCQs भी सॉल्व करना है. तो वी नीड टू अंडरस्टैंड कि Darcy's law के पीछे का लॉजिक क्या है. सो टुडे वी हैव अंडरस्टूड अबाउट द हाइड्रोलिक ग्रेडियंट. Okay, L and A, we don't need to study about it. Okay, because which is quite obvious कि area of cross section जितना बड़ा रहेगा उतना ही पानी आएगा, है ना. अगर किसी सिटी को सप्लाई कर रहे हैं तो हमारे घर में आंगन में पानी डालने वाले पाइप से तो आप पानी सप्लाई नहीं करेंगे किसी सिटी को. उसके लिए आपको चाहिए बहुत बड़ी सी वाटर पाइप्स, है ना. उसके लिए पाइप लाइन चाहिए, उसके लिए हमारा छोटा सा पाइप नहीं चलेगा, राइट. बिकॉज एरिया ऑफ क्रॉस सेक्शन पे ही तो डिपेंड करेगा कि कितना वॉल्यूम वो ट्रांसफर कर सकता है, राइट. So today's class was only about the basics of the Darcy's law. tomorrow we'll be talking about the derivation of the Darcy's law, okay, its variations and its applications and the assumptions. Okay, any doubts?
थैंक यू सो मच सर। अगर किसी को इस क्लास में डाउट हो तो आप पूछ सकते हैं, ठीक है। मिलते हैं फिर नेक्स्ट क्लास में।